All right, so global networking or global networks. So go ahead and watch this video introducing the topic. You can pause this one. Videos on the lecture slides. All right, let's go ahead and continue. So they covered quite a few different things in that video. First thing, we need to define our domain name systems, or DNS for short. So DNS is a system that translates human-friendly domain names. So when you go to Amazon.com, really that's not the way that networks or computers read those addresses. They're actually assigned an actual numeric address or IP address. So this is the way that computers actually read those different website locations on the internet. So IP addresses like 192.0.2.44 or this longer one would actually correspond to this domain. So domains nice for humans to read, but computers read in this numeric format. They use IP addresses. So DNS kind of does that translation. It's a system to translate for humans back to computers. So like I said, IP addresses is what computers use to communicate with each other. So DNS is like the phone book of the internet, right? Amazon.com would be the name, the IP address would be the number. The actual translation process is called DNS resolution. So suppose you had a company called CoffeeNet that has a website hosted in the AWS cloud. So customers enter the web address in their browser. They type in coffeenet.com or .net, whatever the ending is, and they're able to access the website. Now, the reason that these networks are able to communicate with each other, right, or these computers, I should say, in the network communicate with each other, is because of domain name systems. So the computer doesn't see CoffeeNet; it's translated into the actual IP address that makes these connections possible. So DNS resolution involves a customer DNS resolver communicating with a company DNS server. So yeah, DNS is just how addresses actually work on the internet. You don't have to be, we don't have to take a super deep dive right on it, but just know what DNS works at a high level. So for example, when you want to visit CoffeeNet's website, you enter the domain into your browser. It's sent to a customer DNS resolver. So the customer DNS resolver is going to ask the DNS server, hey, what's the IP address for CoffeeNet? And then the DNS server is going to send back the actual IP address that corresponds with the CoffeeNet website. The company DNS server responds by providing the IP address for CoffeeNet's website, which in this example is 192.0.2.0. All right, so DNS resolution, a little graphic. We have our customer and their computer. They want to, they want to travel. If you want to use that word in a sense, to coffeenet.com, right, or any company's website.com. It's going to go to the DNS resolver. The DNS resolver says, hey, they're trying to visit coffeenet.com. The server says, oh, well, this is the actual location. And then it takes them to this actual location. So think of the domain name CoffeeNet, right? Domain names are like Amazon.com, Coca-Cola.com, Google.com, right? Those are the domain names. But the actual locations, right? The actual numeric locations that computers use, you got to use a DNS resolver to get that back to the customer so that they actually get the website. So client connects to a DNS resolver looking for a domain. The resolver forwards the request to a DNS server, which returns the IP address to the resolver. So that request response model, we see it constantly, right, in cloud computing. So it's a good one to cover up front. So Amazon, just like we had a virtual private gateway service called Direct Connect, we have a DNS service from Amazon called Amazon Route 53. Not sure how they named it, but yeah, if you're curious, I'd love for you to find out and let me know. But yeah, Amazon Route 53 is just a DNS system. It's a DNS service. So it helps in registering domain names, resolving the DNS name to its IP address, and routing to AWS resources or external endpoints. It gives developers and businesses a reliable way to route end users to internet applications hosted in AWS. So yeah, that's what Amazon Route 53 is. It's just a DNS system, a service from Amazon. So another feature of Route 53 is the ability to manage the DNS records for domain names. So if you do want to change the domain name for your website, you don't like CoffeeNet, you want to call it coffeeroasters.com. You can do that all on Route 53. So typically you can use other services to do that. Route 53 has that all kind of in-house. So taking care of multiple things for you. So for example, if I want to change domain name, I could use something like Google Domains or GoDaddy.com. But you can also just do it directly through Route 53. So you can also transfer DNS records for existing domain names managed by other domain registrars. See, you can hear transfer DNS records, domain registrars, like I said, GoDaddy, Google Domains. This enables you to manage all of your domain names within a single location. The following example describes how Route 53 and Amazon CloudFront work together to deliver content to customers. Remember, CloudFront is the content delivery network tool. All right, so let's see. Suppose that CoffeeNet's application is running on several Amazon EC2 instances. They're in an auto scaling group, right? So if there's extra traffic coming in, they can definitely recruit more instances. And then they have their load balancer, right? That's the one evenly distributing the work to all the instances. So number one, a customer requests data from the CoffeeNet site. It could be the home page, could be a video, could be all sorts of different types of information. And then next, Amazon Route 53 will resolve the DNS, right? It says, oh, coffeenet.com. I actually need the real IP address, right? Coffeenet.com doesn't mean anything to me. I need this IP address to get them to the right place. So this info sent back to the customer, the IP address. So then the customer's request is sent to the nearest edge location via AWS CloudFront. Remember, CloudFront works with edge locations so that you get your content nice and quick, right? Even if your customers are really, really far away. So Amazon CloudFront connects to the application load balancer, which sends the incoming packet back to the EC2 instance. Oh, we got to refresh this one. Just 1 second. Sometimes the images, I got to reload. So I'm going to, ironically, send a request again to the Canva site. The server resolves the DNS name, sends back the real IP address, and boom, I'm here at my slide deck. And even if the Canva servers were far away, right, CloudFront and edge locations get me that data pretty quickly. I wish it was a little bit faster, but you know, it is a lot of videos and data on the slide deck. Yeah, notice how not everything loads at once. Yeah, a lot of websites do their requests like in piecemeal. So when you're scrolling through like a shopping website and you see that loading as you're scrolling, that's because they're only getting a few products at a time. It seems like you have that infinite scroll, right? But really you're only getting a few things at once. Speed is always important, right? And getting too much data would hurt the speed. All right, so let's go back full screen. All right, so here it is. So your client, it goes to Amazon Route 53 and says, hey, give them the actual IP address so that they can get the data they need. All right, so now I know the actual IP address. I'm going to request the data. I'm going to go to CloudFront because CloudFront's going to use the edge locations to get me that data really, really fast. And then the load balancer, right, is going to distribute that request to the instances evenly, right? So if you're asking for a lot of data, the load balancer will make sure they all do equal amount of work. If you're like bombarding it with requests, then the auto scaling group might ask for more instances to run to handle those customers' requests, and then eventually it makes it back to the client, right? So yeah, they're all working together. So Amazon Route 53 plus CloudFront. Oh, we have a duplicate slide. I think that's it. Yeah, so that's it for this week. I know we covered a lot of different things in networks. That is how it goes, right, with a high level class. It's okay if you feel a little bit fuzzy on exactly how these things work. I can tell you as an engineer myself, I didn't always understand 100% every part of our development process or every part of what we're doing. But if you do understand these things at a high level, right, then you can specialize, right, in different areas of cloud computing. And remember, this class is just an intro course, right? It's just throwing a lot of different concepts and vocab terms so that you're better equipped when you move on to the next course. I will be making an announcement for the next course in the series if you're interested of taking it at LA Harbor College. So definitely look out for that. Keep an eye out for that announcement. There are great professors, right, that teach those classes as well. All right, so that's it for this lesson. And of course, as always, if you need any help, do not hesitate to reach out.